So in this one, we're going to see a bit of everything. We're going to see some sparks. We're going to see some smoke. We're going to see a TV blow up good. This is a Zenith CRT. It's a prism set. It's got a clear cabinet on it, actually a green cabinet. And it has many things wrong with it, all boiling down to a regulator that is not working. And it's sending upwards of 350 volts through the 135 volt rail. This is a prism TV, the type of television that would be given to somebody in a jail. And they're clear. This one's green. I've seen some that are clear. I worked on a couple of these a long time ago when I was in the business. I always thought they were kind of cool. I didn't know what they were at the time. I didn't realize why this TV was clear. I just thought, oh, someone's got a clear TV. That's kind of cool. I always wanted one just because, well, it's beautiful. You can see all the circuitry. You can see the tube and everything inside there. But these were actually made for a special reason. They're used in prisons because inmates would hide contraband inside their televisions and devices. So they had to make them with a transparent cabinet so that they could inspect them and make sure that they weren't hiding knives or drugs or cell phones and so forth and other types of contraband that wasn't permitted in a prison inside it. So that's what these were made for. Specialty market, probably cost a lot more than the conventional black or silver cabinets just because they were made in few numbers, even though the cost of manufacturing would be no different as far as a regular television goes. Just the fact that they had to make a special run with the transparent cases for small numbers would have obviously increased the price. Anyway, this one was brought in. Fellow bought this one off of eBay and it doesn't work. So we're going to see if we can get this one running. So let's see what it's doing or not doing. This television being manufactured in 2000 would make this one an analog only television. So there's no digital tuner on this because this was manufactured before the transition to digital. A device like this is popular in the gaming community because it has an AV input on the front, and of course it's a CRT set. So really all we care about is that the unit operates with the AV input. But let's plug it in. A little bit of a scratch on the tube there on the glass, but that's to be expected considering what it probably came from. This probably was in a prison somewhere. And most of the ones that were in prison, they would actually inscribe the inmate's number on them. But this one here probably obviously that never got done. There's no identifying marks on the unit that I can see. The last one I saw was a clear one and it had a number engraved on the top of it as well. Actually, no, it wasn't on top, it was on the back. But power, let's see what it does. Nothing. Absolutely dead. Do we hear any sound? So what I can hear, if I put my ear right up to it, is I can hear the power supply squealing. So I can hear the chopper transformer. This one has a switching power supply. You can see it right down in the middle. Right down, well, I guess you guys can't see it with the reflections, but there is a switching transformer inside this one. I'm gonna pull the back off this set now because it was an institution set. Of course, they don't use regular screws. Oh no, these ones use security Torx. Let's see if I've got one that's big enough. I hope I've got one that will fit it. It's quite a large security Torx. I know I've got one around here somewhere. It does. Excellent. This is a cordless screwdriver, but the battery is long expired on this, so I just use it as a regular screwdriver. By security Torx, you'll see what I mean. It's got the pin in the middle, right? So the bit has a hole in it like that, you see. That was done for a reason as well, to stop inmates from opening the set up and putting stuff inside it, even though being a clear case, it would be kind of hard to do that. You know, the back cover will just lift straight off, just like any other television. Okay, the first thing to check, obviously, is the horizontal output transistor. That's the very first thing to check. And it appears to be shorted. So we'll remove it and see if it's still measuring shorted when it's out of the set itself. Output transistors failed. Could be the transformer has taken it out, or it could be a broken connection that's caused loss of drive, which will also cause them to fail, or power surges and stuff. This transistor actually is okay. It's got an internal damper diode, which is what we're seeing with the meter across it. So this transistor is good. And I have another one, and it measures exactly the same as this one. So this one is in good shape. So we'll look elsewhere, see where the problem might be on this set. So just replace the transistor. And we'll start looking back at the power supply, see whether we're getting any voltages. Alright, so let's check the power supply out. We'll first check our raw DC, which is 167 volts, which is normal. That's on the hot side. We go over to the cold side of the power supply. Let's just see whether we're getting anything coming off of the main rectifier here, which is, where are we here? 12 volt supply. This is the DC cold ground. I got nothing. I can hear it buzzing. There's nothing, there's no voltage here. And the other supply here is, what's that, the 135? There'd be nothing on that too. And there's nothing. But it could be because there's a short and the whole set is everything's being pulled down to nothing here. So let's just take a look and see whether there's any shorts on the DC side, or the transformer, the low voltage side, the isolated side. Because we know that when I measured the output transistor, it was measuring a short. But where is that short coming from? Is it internal in the transformer, which it might very well be. It might be the flyback transformer is shot on this one here. Okay, I got a short across that diode. That diode can be shot too, for that matter. That one's okay. That one there is. That one's okay. This one here. That diode could be shorted. I'll take it off right here. I'll take the horizontal output off. So this is removing the horizontal output from the path. So now I can measure again and see if I've still got a short, because if it was the transformer that was causing the short will go away. So are we still shorted? We are. If we measure between the transformer, you see now the short's gone. We no longer have a short because I've disconnected it. So we're going to check back and see whether it's the diode that's bad or whether it's this capacitor is shorted internally. Somewhere in here, or even the Zener diode. The Zener diode could be bad. That might be it here. You know what? There's a Zener diode right across here that would blow if the voltage went too high as a failsafe. I bet you that's where the fault is. Let's just disconnect that little Zener diode. We'll just take out this Zener diode here and see whether this is the fault. Because if the power supply were to go too high, the Zener here would crowbar and take everything down to 0 to shut the set down. This is for X-ray protection. So I'm going to power it up without the set connected, without the transformer connected, if this is in fact the short, and we'll measure what the 135 is measuring. First of all, we'll measure that Zener and see if that's the short. Looks like it is, because the short's gone away. So let's just pop that Zener out, and then I can pick up a Zener today when I go to town. Okay, let's just check our voltages now. We are at 121 volts. That looks pretty normal there. Oh! I see smoke! I think the flyback's shot. Oh, beautiful! I see beautiful smoke. Where's it smoking from? Oh, this cap is blown. Oh, cool. This is probably the one that was over voltage there. And this cap just went up in smoke. So maybe it's not the flyback. Look at that. It's all... Oh, it's toasty too. Toasty, toasty, toasty. Let's just change out that cap. Well, I don't know if I've got one high enough rating though. I may have to get one for that, because that's going to be like probably a 150. What is this? 100 microfarad at 160. I might have one. Okay, I've got another cap in here. This one's a little higher capacity. It's rated at 250 volts. Shall we check the voltage again and see what it goes up to? It only went to 120, but again the damage may have been done on that cap. Between ground and here, 122 volts. So the voltage looks to be normal. Will this set turn on? I don't hear any high voltage coming on though. So obviously something blew up. What blew up this time? So obviously there's a regulation problem on here. The set's not starting though. There's no high voltage. So what else is wrong with this thing? It blew this one over here. One of the other ones blew on this thing. It blew another cap. Well, let's remove that one. This one is it's only 85 degree. 1000 at 16 volts. 85 degree cap blew up on it. Interesting. Okay, we got a problem on here. A regulation problem or something that's causing that voltage to go too high. We'll just put another one in for this. See what else blows up. Again, the set didn't turn on when I hit the power button. Nothing happened. There's no high voltage. So let's just replace this one and check the voltage again. So I've got a new one. This one's a 1025 that I put in. So here's my 135 supply. I'm measuring 108 now. It's low. What about my other supplies? What about my 12 volt supply? What is it? 8 volts. It's low. The set won't turn on either. What blew this time? This thing keeps blowing capacitors up. So this time, the cap that blew is over here. What the hell is going on with this thing? Did this thing have such a catastrophic failure that it's popping caps? Obviously it's not regulating properly, but I mean the other voltages seem to be okay, but this one here blew. This is another 1000 at 16 volts. We'll just pop another one of those in and see what blows up next. We're sitting at 106 now, which is low. It should be 135. But the set isn't turning on. At the the horizontal output transistor here. We've got, what do we got on here? We should have our B plus should be right here as well, which we don't have B plus. Oh, is this resistor open? That resistor looks like it's open. Okay, there's a resistor open here in the B plus. This resistor just appears to be open. This is, what is this value? Yeah, this resistor is a 0.82 gray, red, silver, and it's open. Okay, here's another one. That one's okay. Remember the resistance of my leads, right? You gotta wonder what happened to the set when it broke. What made it blow up in the first place? What blew the Zener? Why the voltage went too high, which blew the Zener, which has led to other components failing. What's going to go boom next? I'm scared to plug it in. Okay, we got how many volts here? We got nothing. What the hell? What about on our 12 volt supply? Like, we got nothing on here now. I wonder if it is that flyback that was bad all along. Because now that I've reconnected the like the resistor went open on that B plus supply, now I got no voltage. Like I got 0.3. And I can hear this thing humming away, like it's trying to run. I wonder if the flyback's what was the root cause all along. It's shorted. Okay, I got the output transistor out again. It's measuring shorted. So we may have popped the output transistor. I'm going to just fire this thing up without the output transistor in. I want to see if I get horizontal drive. So I'm going to get the scope on, and we'll connect the scope up to the drive transformer here and just see whether I'm getting any drive signal for this. If we get our horizontal drive, then we'll try a new transistor. We have drive. But this thing just evaporated another capacitor. My horizontal drive is there. I just turned it on and was setting up the scope to get a shot of it. And another cap let go. Which one's gone on here now? This power supply is obviously running hot. What blew? What blew this time? This thing's popping capacitors left, right, and center. You should see another one with the top blown up on it. It's obviously none of the ones that I've changed, but I bet you it's this one here. I bet you that one let go as well. So obviously the high voltage is going too high is what our problem is on this. I bet you it's this one here is gone. Oh yeah. Yeah, this one here is it's gone toasty. It actually melted the bottom on it. I'm running out of capacitors to put into this thing. It's obvious that the regulation's not working. Regulation's going to be this IC right here. That's the drive IC for the regulation. I hope it's not shot. That would certainly explain everything. But yeah, this is blowing another 100 microfarad, 160 volt cap. I've got another one kicking around here somewhere. The air is getting pretty bad in here too. I got the door open and it's still smoky as old hell. Okay, another cap in place. I'm going to put my meter on here. Just when I power it up, I'm going to clip my meter on. I want to monitor how high that voltage goes on initial startup, because popping caps like that, indicates that the voltage is way too high. Yet when I measured it, it seemed to be well within where it's supposed to be. So let's just measure. I'm just going to clip my meter on so that I can do some measurement. This is my 135 supply. I'll show the scope in the shot at the same time so you guys can see that the drive signal will come on, because I'm not going to leave this thing run for more than a few seconds. I don't want to have any more capacitors go boom on me. This is enough. Enough is enough, as they say, right? But they all could have been damaged initially before and just failing one at a time because they were all over voltage in that first initial over voltage. So 126 volts, okay? We should not have caps blowing up at 126. If I hit the power button on here, you'll see that we have a drive signal that set tried to start. Now the voltage shot way up. Wow, what the hell? That's why the caps are blowing. Hit the power button and that voltage shot up to 300 volts. Holy crap. Well, that would explain why the caps are exploding. I've never seen anything like that. We certainly do have a regulation problem on this set, and it's going to be something in this regulation circuit here. I'm going to have to look up the schematic for this thing to see where it's getting its reference from, because obviously it's not getting a reference, or something else is shorted, which could very well be one of the other parts has got a failure, and when the set tries to come on, the voltage drops on one of the other supplies, which is being used as a reference, and then the thing just goes right through the roof. That would certainly explain why caps have been exploding. As soon as I try to turn the set on, the voltage goes through the roof. That would also explain why that Zener also failed. Okay, I'm going to monitor the 12 volt supply. The 12 volt supply appears to be the one that is used as a reference to the voltage regulator IC over here. So if the voltage goes up on the 12 volt supply and the power supply is not regulating it back, it could have a problem with this regulator. I'm only going to leave this thing on for a very, very short amount of time. It's at 8 volts now, which is low. Which is probably why the voltage is going so high. But let's just hit the power for a second and see that shoots way up. So the power supply is not regulating, because that voltage going up like that is directly referenced to this regulator over here, and that should be cutting back and keeping that power supply in regulation, which is not. So I get a sneaking suspicion it's this regulator right here that is at fault. This hybrid part, this one here, it's on the ceramic board. This has got the optocouplers and everything on it, and the voltage regulator, and that is where I think our problem is that failed. That caused the voltage to go too high, which ultimately blew the crowbar and shut the set down. So that is we're gonna have to try to source that part, because I'm sure that that's probably where the fault is on this. The very fact that it is not controlling the voltage. It's interesting that when it's not turned on, the voltage is low, but that's also probably because the regulator's not operating. It's just operating in a standby mode. On the regulator, okay, I got a ground. This one's ground. This one monitors the 12 volt supply, and this one here monitors the 135 volt supply. This is what's controlling the output, which controls the chopper. This other pin here, this is a switching pin, which comes off of the IC over here, which is what's going to turn the unit on from standby to full power. The fact that the voltage is not being controlled and the voltage is going way too high is an indicator that one of these is not detecting the input voltage and is not responding accordingly. So we have a regulator problem on this set. This module is where our fault is going to be. I don't know if it's this connection problem on here, one of the thin film parts, but this is where our fault is going to be on this one. It's not providing feedback. There's optocouplers here, which is what controls the oscillator, which is what controls ultimately the voltage. If we look at the scope, this is when it's in idle, before the set's turned on. I'm just monitoring the output from the, this would be the drain off of the MOSFET. Turn the set on momentarily, we'll watch that waveform and unplug it right away, but when we turn it on, okay, so the power supply is idling in the what they call the standby mode, which is just pulsing. That's what's keeping the voltage low. That's to keep the set alive for the standby circuits and stuff. So it just pulses the regulator on and off, and then when the set turns on, it goes into full regulation mode, and that's not happening. If we monitor the turn on between ground and the turn on pin, which one was that? It's coming off the IC here. It was this one here. We'll see that the signal will change when it goes into turn on mode, but it's not regulating. So now the meter's connected to what should be the turn on signal for the regulator. So when I hit the power button, we should see the voltage change, which it does. It goes to 5 volts. That's telling the regulator that it should turn on, and the regulator is not turning on. Therefore, we know what the fault is on this. This one here has a faulty control regulator IC. And that's all I'm going to be able to do on this one at this point, because without that part, the set is not going to work. I'm going to leave it at this point, and I don't know whether I'm even going to be able to find a part for this. I'm going to get a hold of the guy that owns it. He didn't pay a lot. He just bought this thing, and it was broken when he bought it. And he told me he paid $30 for it. So I don't know how far he wants to go on this thing, but we've got a couple caps I've replaced on it already that blew up thanks to the voltage being off the end of the scale, which was something that was completely unexpected. But then you never know with these old sets like this. You get what's called multiple component failure, and you get one part that goes bad and it blows others out. And yeah, I know I removed the Zener, but even if I had replaced it with another Zener, of course, as soon as the power came on, it would have blown it immediately. So really, there's no way to test this thing without being able to run it, even at reduced voltage. But with a power supply like this, these things can generate an enormous amount of power, as you saw. So even if I run it on a variac or on a dim bulb or anything, it doesn't matter. As long as this thing oscillator is running, that voltage is going to go through the roof. Anyway, I'm going to leave it at this point and throw this together for now and get a hold of the guy that owns it. hey, at least you guys got to see a smoke show, right? Thanks for watching. We'll pick this up again if I can find a part for it. We'll catch you in the next one. Bye.